In this video segment, we're going to take a look at part 2 of the exam and review problems 3 and 4. So problem number 3 was once again about BJSG ribs in Thatcher, Idaho. We took a look at a labor demand and a labor supply relation of 75 minus 6W for labor demand and negative 10 plus 4W for labor supply. We indicate it's a profit maximizing firm in a competitive market and that the firm hires moderately skilled workers who understand that barbecued ribs and Dr. Pepper have their own place in the food pyramid. And you should know that's consistently true, by the way. So first we need to identify the market clearing a wage and quantity of labor for this firm. We do that by setting the labor supply equation equal to the labor demand equation such that we end up with 75 minus 6W equals negative 10 plus 4W. We can then solve that down such that W star equals 8.75. And then we can put that value of W or W star into either the labor demand or the supply equation and substitute for W, and we end up with a L star of 24. Here I've gone ahead and put it into the labor demand equation. I know it's labor demand because it's got a negative before the scalar, and so it gives me 24. I could have put it in labor supply just as easily. To go ahead and complete this model, I need to go ahead and find the intercepts for both labor supply and labor demand. I'm doing this in the normal way by setting each of the variables in either of these equations equal to 0. So I take labor supply to begin with. I set W equal to 0, and it gives me labor supply is negative 10. Well, negative 10 on the labor supply, which is the labor, or the x-axis, is going to be out here somewhere. And then I set labor supply equal to 0, and I have 0 equals negative 10 plus 4W, or 4W equals 10, or W equals 2.5. And this is on the wage, the Y or the W axis, and it's at 2.5. I've done the same thing for labor demand, of course, setting the wage equal to 0, which leaves me with labor demand equals 75 minus 6 times 0, or just 75. And then I set labor demand equal to 0, and it leaves me at 75 minus 6W, or 6W equals 75, or W equals 12.5. So here I have 75 is LD, and 12.5 is W. And here I have W is 2.5 for labor supply. I could connect this back here with the labor axis, but I already know that labor demand and labor supply are the same thing. They equal one another. They cross at 8.5 equals W star, and 24 equals L star. So I can go ahead and just go ahead and put this curve in place, and using those 2 points, 2.5 and then this equilibrium point. So that's what you needed to do for part B. This other labor demand curve that's been shifted out and to the right is for one of the other parts in another a little bit later on in this particular problem. So as we go further, I ask if another employer entered the market such that labor demand increased generally to LD equals 85 minus 6W. By the way, that's what this curve represents, LD equals 85 minus 6W. And I say this might have an important impact on BJSG's business operation. How many workers would the firm choose to employ at that wage? And I give you a hint in saying that we need to assume that BJSG's labor demand hasn't changed. So it's still 75 minus, still 75 minus 6W. Well, in order to solve this now, I need to find the new equilibrium level of wage and the new equilibrium level of labor. So I'm going to take and equilibrate or set equal to one another the original labor supply equation of negative 10 plus 4W. The supply of labor in this market hasn't changed, just the demand has. And I'm going to set that equal to 85 minus 6W, the new labor demand equation. It's going to yield then, as I work it through, a wage or a W star of 9.5. If I put that W star into either of these equations for the modified labor demand or the original labor supply and substitute it for W, I'm going to find that the new L star is equal to 28. Well, that's great. That tells me the total number of workers that are going to work in this market at the market clearing wage of 9.5. And it doesn't create any friction in the market. We just have a new market equilibrium, but at a higher wage. I've indicated here that BJSG's labor demand hasn't changed, so it still has a labor demand equation of 75 minus 6W. If I now take that wage of 9.5, substitute it for W in the labor demand equation for BJSG, I end up with labor demand for BJSG of 18. That's important to note because in Part D, I've then said, okay, assuming BJSG changed the number of workers to accommodate this change in the market. So they went from 24 workers that they might have had down to 18 now, and they kept as many employees as the firm demanded at that wage, which is the 18. How many workers would the new firm in the market be able to hire and at what wage would it hire them? Well, it's going to hire them at 9.5. That is the new market clearing wage. That's the wage that BJSG has to pay in this market. It's a competitive market. I indicate that in the leading story. But also, there are only 28 workers available in the market, of which we now know BJSG has hired 18, and that leaves 10 for the new firm. So in Part E, I ask you to go ahead and identify the new labor demand relation on the original graph in Part B. So I've gone ahead and put this here, and as I set the intercepts for the new labor demand, I find that we're going to intercept the W-axis of 14.17 and the L-axis or the X-axis is 85. I did that here in this equation by, once again, taking each one of the variables for the labor demand, setting it equal to 0, and it gives me the intercepts. So when I set W equal to 0, it gives me LD equals 85 minus 6 times 0, or just LD equals 85. When I set LD equal to 0, it tells me that 0 equals 85 minus 6W, or 6W equals 85, or W equals 14.17. So the new labor demand curve shifts out and to the right. Labor supplies remain constant. We don't have any new workers in the market. Now, we may have a new number of workers that ultimately is employed because we end up moving along the labor supply curve as the labor demand curve is shifted. See, we're simply moving along the labor supply curve as the labor demand curve is shifted. So that's number 3. And then finally, number 4. The following labor supply and demand equations are again for BJSG Ribs in Thatcher, Idaho. Got the same exact labor demand and supply relation of labor demand is 75 minus 6W, labor supply of negative 10 plus 4W. And once again, profit maximizing firm in a competitive market, and we have our eternally true aspect of barbecued ribs and Dr. Pepper having their own place at the top of the food pyramid. So we're assuming that BJSG once again has the same labor demand as the market. By the way, you see in this that I've given a couple of notes here with these questions that are in pencil. Those are because I made some changes to this exam after I took it, but before you did. So my notes in pencil that are with these questions were telegraphed, and those that were actually typed on the one that you took. So just as I did in number 3, I set the labor supply equal to labor demand to find the market clearing levels. Again, we have W star equals 8.5, L star equals 24. I got this the exact same way I did in number 3. I go ahead and ask you to give me a properly labeled and appropriately articulated labor model for the market in which this firm operates. I say be sure to label everything properly. I come across my intercepts the exact same way I did before. I already found my equilibrium. I can go ahead and put together my model now. And this labor demand curve, labor supply curve, equilibrium, etc. are all a function of those labor demand and supply relations that I initially had on the wage and the labor axis. These additional values of the minimum wage at 10 and that begats a labor demand and labor supply of 15 and 30 respectively are a part of another element in this question as we go to the next page or two. Which I see I've left off of this. And so I will actually create another video segment including that, and we'll ask your apology.